Alright guys, let's go ahead and get started with our video. This one's going to be on limiting reactant, which is what you see right here, and of course the excess. This is going to be like every other video. The only thing is, on this one I'm going to be asking you for very specific things throughout the video so you can turn into me. The reason I'm doing this is I want to make sure that everybody's doing their part and that you guys are actually watching the video, at least if not all the way through, at least into the part where you do get through it. Now, let's go ahead and take a look at these two blocks. I have a block here, and I have a block here. And I'm going to use these blocks to kind of explain a little bit what is the limiting reactant. Now, when this block, let's say chemical A or reagent A, reacts with reagent B, we get a compound of reagent A and B. Now, the whole premise behind limiting reactant is that these are not always nth equal quantities. For example, you can obviously see that there's less of this guy than there is of this guy. And I can demonstrate that even clearer, where if I move this guy right over here, you can kind of see that obviously there's more of chemical A and then there is of reagent B, for example. So the whole premise behind limiting reagent is that as this guy gets used up, there's going to be some of reagent A left over. Okay, that reagent or that excess is what we call the excess reactant, the one that's going to have leftovers, right? The one that doesn't have leftovers, the one that gets completely used up, in this case the pink one, right? The reagent B, that one's going to be the one that's going to run out first. So once this guy runs out, then the reaction stops because there's no more of A and B to make AB. There's only reactant A, which is the excess, right? So that's the whole premise behind limiting reactant. You need to figure out which one this one is, because it could be either here or here, right? In this case, it's obviously here. When you're doing a balanced chemical equation, it's not so clear. So once you figure out which one's the one that's going to run out first, then you can calculate how much of the product is going to be made. So for this experiment here, we're going to go ahead and label this guy the excess, and this guy is our limiting. Okay, and the one that's going to dictate how much product is formed is the limiting reactant right here. Okay, so that's the basic understanding of what is the limiting and the excess reagent. So I'm going to go ahead and move over to the slide here, and we're going to go ahead and solve a problem. Alright, now the question reads, in a reaction, 51.2 grams of magnesium phosphate reacts with 30.4 grams of silver nitrate. How many grams of silver 1-phosphate forms in this reaction? Okay, well, there's our information, right? Pretty much everything we need to know is here. 51.2 grams of magnesium phosphate, that's this guy right here, right? Reacts with 30.4 grams of silver nitrate, which is that guy right there. Okay, and then we're looking for how many grams of silver phosphate. That's going to be this guy right here, right? So to kind of make it easy on ourselves, let's just go ahead and put a little star next to the unknown, right? That's going to be our unknown right there. Once we figure that out, then we got to figure out which one of these two is going to be the one that runs out, right? We need to determine which one is the limiting reactant. So let's go ahead and list all of our givens. Okay, so first given, we're given 51.2 grams. See, so our first given here was right here. I'll go ahead and underline it here. That's the 51.2 grams of magnesium phosphate. Alright, so there's our first given. Our second given is right here, which is the 30.4 grams of silver nitrate. Alright, so we have our first given and our second given. Okay, now we know our givens are, so what's the unknown? The key to finding the unknown is looking for keywords. Keyword, for example, is like how many. How many usually follows or precedes, the unknown. So how many, and then here we go, silver phosphate. Now, what are we looking for in silver phosphate? Are we looking for moles? Are we looking for grams? Well, usually that's in the question, and right here it shows you you're looking for grams of silver phosphate. So I'm going to go ahead and underline that. Grams of silver phosphate. So our unknown then is going to be the silver phosphate, which is why we put the little star right here. Alright, so let's go ahead and add that to our list. And there we have it, grams of silver phosphate. Okay, so now we know exactly what we're looking for. Okay, our givens and our unknown. Alright, so let's go ahead and start working out the problem. Now, when you're working out these types of problems, the first thing you got to figure out, okay, is you got to ask yourself this question. The question you want to ask is, are my given quantities already in moles? Okay, so let's take a look at our givens. Alright, our givens are here. Okay, so are our givens in moles? Yes or no? Okay, if the answer is yes, then you can go ahead and move on to the next step. If the answer is no, then you have to convert everything to moles. So in our case, the answer to the question is a very plain and simple no. They are not. Right? So because our givens are not in moles, we're going to go ahead and take this opportunity now to set up the conversion, and let's just get everything in moles. Remember, right, when you do these types of problems, you're using mole ratio. So if you know you're going to use mole ratio, you know you have to have everything in moles. So let's take a minute and let's go ahead and set up the conversion to make sure that all of our quantities are in moles. And that's just going to make our lives that much easier. Okay, so let's get started. Alright, the first given that I'm going to convert to moles is going to be the magnesium phosphate. So what I'm going to do is I'm going to go ahead and set up my conversion. 52.2 grams of magnesium phosphate. Okay, I'm going to put my given over 1. Now I know that when I convert from grams to moles, I'm going to use molar mass. Right? So because I know what the molar mass is, alright, I know that 1 mole of magnesium phosphate has an atomic or a molar mass of 262.855, right, grams of magnesium phosphate. Okay, now I set it up this way to make sure that my grams cancel out. Okay, once my grams cancel out, then I multiply everything across the top, everything across the bottom, and then I divide at the end. And when I get that answer, my moles here, I end up with 0.194784. And the unit is going to be moles of magnesium phosphate. Okay, so 1, done. Okay, let's go ahead and just convert the other one now and save ourselves the headache, right? Alright, so let's go ahead and move on here. The next one is going to be 30.4 grams of silver nitrate. Okay, same thing. When I'm going from grams to moles, I'm going to go ahead and use molar mass. If you don't remember how to do these conversions, go ahead and go back to the video that we made on converting from grams to moles, moles to grams, and that'll explain how to find molar mass. Okay, there's another video for molar mass if you can't remember how to do that. But for this case, we should already know how to do this. I know that in 1 mole of silver nitrate, there is 169. 1 mole of silver nitrate. There's 169.872 grams of silver nitrate. Okay, now once I have this, I know that my grams of silver nitrate are going to cancel, and once those cancels, the only unit that's left is moles of silver nitrate. So my answer, once I multiply straight across and divide, I'm going to end up with 0.1789 moles of silver nitrate. Okay, so there is my moles of magnesium phosphate and my moles of silver nitrate. So at this point, I want you to go ahead and I want you to write down the conversion from grams to moles of silver nitrate. That's going to be the first thing you're going to turn into me. It's just this conversion right here. Alright, pause the video, finish copying everything down, and then we're going to go ahead and pick up where we left off, okay? So I'm going to give you few minutes here. Go ahead and pause. Okay, we have a nice clean slate. If you need to go back and finish copying something down, pause the video, rewind it, and finish writing it down. Okay, but we're going to go ahead and move on. Okay, next question we want to ask ourselves is, do we know the limiting reactant? Well, where are the reactants on the balanced chemical equation? Well, the reactants are right here, right? These are your reactants, these are your products. Now, one of these is going to run out first. At this point, we need to figure out which one of these is going to be the one that runs out first. Now, lucky for us, we already did a conversion, right? So we know that we have 194 moles of magnesium phosphate. Okay, and we also figured out that we have 0.1789 moles of silver nitrate. Okay, we did this on the last calculation. So the good thing is that everything, we already have it in moles. So now what we're going to do is we're going to figure out which one of these two is going to run out first. And we do that with none other than our mole ratio. So if I'm going to do a mole ratio from here to here, right, I'm going to write it down in terms of the coefficients. So my mole ratio is that for every 1 mole of magnesium phosphate, I need 6 moles of silver nitrate. Right? There's my mole ratio. That's the one I'm going to use. And see, this is why you need things in moles. Because can you cancel grams with moles? No. Everything has to be in moles. So I just like to get that out of the way first. So let's go ahead and set up the conversion then, okay? Going from here, I'm going to pick one. In this case, I'm going to go ahead and just pick the 0.194784 moles of magnesium phosphate. Alright, there we go. Little 3 in there that you can barely see. I'm going to put that over 1. Then I'm going to multiply by my mole ratio. Now, the mole ratio says that it's 1 over 6, right? See, 1 over 6. But I need to cancel out magnesium phosphate, so I'm going to have to flip it. So 1 mole of magnesium phosphate has to go at the bottom because I want to cancel units, right? And my 6 moles of silver nitrate is going to end up on top because that's the unit that I want. So let's go ahead and cancel our units. Here we go. Alright, those are canceled. And to find the answer, I'm going to do it is I'm going to multiply straight across the top, straight across the bottom, divide at the end, and my final answer is going to be 1.1686. And that's going to be moles of silver nitrate. Okay, so what did we do here? Alright, it's very simple. For this reaction to work, I'm starting with this amount. Okay, and what this calculation tells us, since it says this: if I have 0.194784 moles of magnesium phosphate, right, how many moles of silver nitrate do I need to use all of this up? By doing this calculation, we figured out that we need 1.1686 moles of silver nitrate to use all of this magnesium phosphate. Alright, so we call this the need. This is how much I need of silver nitrate. Okay, now this number here, our given that we converted to moles, this is what we actually have of silver nitrate. Right? So we have 0.1789 moles of silver nitrate. Right? This is what we actually have. Okay? So this is what I need. This is what I actually have to work with. Now, all you got to do at this point is figure out which number is bigger, 1.1686 or 0.1789. Okay, it's pretty simple. This one is bigger, correct? So if you agree, then ask yourself this question. If the need is bigger, do I have more or less than what I need? Well, this is your have, right? So since that have is the smaller one, then basically what's happening is you have less than needed, right? I need a certain amount and I don't have enough. So if you have less than what you need, then your silver nitrate then, because remember this is all silver nitrate, we're comparing the same thing to each other, the silver nitrate is going to be the one that runs out first. And if that's the one that runs out first because you don't have enough, then that's going to limit the reaction, and that's your limiting reactant. Now if silver nitrate is the limiting, then magnesium phosphate has to be the excess. Right? So now you've identified which is the limiting and which is the excess. Now, the second thing you're going to turn into me is I want you to turn in this comparison right here. Right? Write that down next to the other question that I asked you. Okay? And this is the second thing that I want turned in from you. So on a separate sheet of paper where you're writing down all the things I'm collecting, go ahead and include this comparison right here. Alright? Go ahead and pause the video. Make sure you have everything written down. If you have any questions, feel free to rewind it, watch it again. And if you're still not clear about something, go ahead and come up to the small group and ask me directly. It's okay. All right. I'm going to go ahead and give you just a few minutes to finish writing this down. I'm going to clear the board, and then we're going to continue on with our calculation because we're still not done, right? We just figured out which one was the excess and the limiting. Here's your excess, here's your limiting. But we still have an unknown, guys. We still got to find that unknown. So go ahead and finish writing this down, and then we'll pick it up in just a few minutes. All right. So if I erased everything or you didn't finish writing something down, go ahead and pause it, rewind it, finish it up, and then we'll continue exactly right here. But let's go ahead and move on. We already figured out then that our limiting reactant, right, was equal to the silver nitrate. Yay! Right? So that's going to be the one that dictates how much silver phosphate is formed. So now I know that I'm working from silver phosphate to silver nitrate. So what I'm going to do is I'm going to identify the mole ratio. In this case, the mole ratio is for every 6 moles of silver nitrate that reacts, I produce 2 moles of silver phosphate. Right? So there's my mole ratio. Now, because silver nitrate is a limiting reactant, I have to use the mole ratio from silver nitrate to silver phosphate, right? Because we said earlier that's what's going to limit or dictate how much product is formed. Luckily, since we converted everything to moles earlier, we can just go ahead and start from our moles. So I know that I have 0.1789 moles of silver nitrate. Go ahead and put that over 1. Then I want to multiply that by my mole ratio. Okay. Now, my mole ratio, we already found it, right? It's right here. What we have to figure out, though, is which one do we want to put on the bottom? Do we want to put the silver phosphate or the silver nitrate? Well, you got to remember that you got to cancel units. So I'm going to put 6 moles of silver nitrate at the bottom to make sure those cancel out, and 2 moles of silver phosphate at the top to make sure that I end up in the desired unit. In this case, silver phosphate. So what happens to silver nitrate? Those moles cancel out. Multiply everything across the top, multiply everything across the bottom, and then you divide at the end. Once I go ahead and do that operation, I'm going to end up with 0.059 633 moles of silver phosphate. Right? That's how much product is going to be formed. Right? Silver phosphate. Now, I want you to pay attention. Let's go ahead and go back to the little window section over here, and I want you to take a look at the unknown that we wrote earlier. Is that unknown in moles or is that in grams? Okay. Well, the question is asking for grams. See, look, I'm even going to circle it again right here so you can see that it's asking for grams. So because it's asking for grams and this unit is moles, are we done? No, we're not done. We have to convert these moles to grams. And I'm going to use that using molar mass of silver phosphate because I know that 1 mole of silver phosphate has a molar mass of 418.575 grams of silver phosphate. Right? Once I do that, I multiply straight across, these cancel, and I end up with 24.9617 grams of silver phosphate. Okay, and there we go. Now we've calculated our unknown. Our final answer gets boxed in, and guess what? This is the last thing you're going to turn into me, right? I want you to go ahead and turn in this number, and those are the 3 things that I'm going to ask you to turn in or collect at the end of the period. If you didn't finish the video, go ahead and turn in the previous 2, and we'll go from there. I understand sometimes the videos get a little bit close, but this is the final answer. Go ahead and pause the video if you need to write down anything else. Feel free to rewind or watch it again. This is going to be posted up on the Weebly page so you can watch it whenever you want. Alright, I hope you guys that this is a little bit more clear. If you have any other questions or you want to try something else in class, just let me know. But we ended up with 24.9617 grams of silver phosphate using the mole ratio and determining which one was the limiting reagent. Alright, I hope this helped, and give me some feedback on the page. Let me know if you guys need anything else. Later, guys.